Hello, we are going to be discussing absolute value functions in this video. Some of the examples and notes come directly from the OpenStax free online college textbook, or college algebra textbook, and it's from 3.6, the section 3.6. So absolute value functions. So we're going to start off with what I think are the more confusing problems. So a lot of people have trouble with application problems. So when you've got sentences and then you're trying to transcribe that into algebra, that sometimes causes problems. And these to me are a little confusing. So I want to go through these. Keep in mind we're doing absolute value functions. So we're going to have an absolute value in these. So number one, describe all numbers x that are at a distance of 4 from the number 8. Express this set of numbers using absolute value notation. Okay, so here are some key things. First of all, at a distance of 4. Remember that absolute value is the distance from 0, usually. Here we're going to say at a distance from the number 8, but it's a distance. And remember, a distance can be in both directions. On a number line, you've got a distance to the right and a distance to the left. So when you're talking about distance from a number, you're going to be thinking of absolute value. So that's kind of the indication here that we're using absolute value. Also the fact that it says absolute value right here, okay? But if it didn't say that, you know that you're looking at the absolute value because it's a distance from a number. So whatever you're having a distance of, that's going to be what's on the right-hand side of the equal sign or the inequality sign. So describe all numbers that are at a distance of 4 from the number 8. Okay, so from the number 8. So that's how you're going to write it. The absolute value of x minus 8. So the number 8, the distance is 4. Remember that if I said something like this, this would be the distance from 0. So this would be the distance from 0. If I want to have it be an 8, I'm going to have to do the subtract 8. And remember that it's the opposite of what you think when you plug it in. So it's going to be the x minus 8 equals 4. That is how we can express this set of numbers using absolute value notation. So there's the absolute value. Now, let's say I wanted to check it. So let's just think through logically. Describe all numbers that are at a distance of 4 from the number 8. So if I want something that's 4 units away from 8, if I go this way, that will be a 12. And if I go this way, 4 units away from 8 is 4, right? So this way I subtracted 4, this way I added 4. Okay, so by that logic, I can see the two numbers are 4 and 12. I can check my equation just to make sure it works. So x minus 8 equals 4 and x minus 8 equals negative 4. That's how you solve an absolute value equation. Add 8 to both sides. I get x equals 12, so that number checks. Add 8 to both sides here. I get x equals 4. That number checks. So that means that this I verified is the correct equation. Okay, so now let's look at the next one. We have find the interval of numbers that are at least a distance of 7 away from negative 8. Write the solution as an interval or union of intervals. All right, this one's a little bit different. The key to knowing that we're going to have to start off with an absolute value is it's a distance away from a number. But here it says at least 7 away. Okay, so it's at least 7 away. That means we're going to have at least 7 away. So whatever it is, the distance is greater than or equal to 7. Since it's a negative 8, we're going to say plus 8. So the absolute value of x plus 8 is greater than or equal to 7. Now, it doesn't just want us to write it using absolute value, it wants us to write the solution as an interval or a union of intervals. That indicates we need to finish solving this and use interval notation. So in that case, if you don't remember how to solve the absolute value inequalities, go back and find a previous lecture that deals with that. I'll kind of walk you through it, but I'm not going to give all of the details here. What we want to do is first we want to make sure the absolute value is by itself. It is. Then we check this symbol. This is a greater than symbol, so that's important. Since it's a greater than symbol, we know to solve this by breaking it up into two inequalities. The first one is going to be x plus 8. Flip the sign, change the sign. So it's going to now be less than or equal to a negative 7. And then the other inequality is going to be exactly the same as it was without the absolute value symbols. And now we're just going to solve. So minus 8 from both sides. We get x is less than or equal to negative 15. Minus 8 from both sides here. We get x is greater than or equal to negative 1. And so now we have two different intervals. The first interval is negative infinity to negative 15, union negative 1 to infinity. So here is our answer in interval notation. And it does match what it said to do because we have a union of intervals. Okay. So number 3. The next part in this section, we're going to be asked to find intercepts. So find the x and y intercepts of the graph of each function. You don't have to graph it to find the intercept. You can simply plug in 0 for one or the other points, one or the other coordinates in the ordered pair. So for example, if I want to find the x-intercept, or intercepts, depending on the case, I let y equal 0. So remember that f of x is y, so I'm just going to set it equal to 0. So negative 3 times the absolute value of x minus 2 minus 1 equals 0. When I'm solving an absolute value equation, the first thing I want to do is get the absolute value by itself. So I'm going to start by adding 1 to both sides. So that'll give me negative 3 times the absolute value of x minus 2 is equal to 1. Divide by negative 3. So that's going to give me absolute value of x minus 2 is equal to negative 1/3. Now I have the absolute value by itself. It's set equal to a negative. So what does that mean? That means that there's no solution, right? An absolute value cannot be negative. So this is no solution, which means there are no x-intercepts. Okay, so now let's look at the y-intercepts. If we want to find the y-intercept, we're going to let x be 0. So negative 3, so y equals negative 3 times 0 minus 2 minus 1. So 0 minus 2 is negative 2. The absolute value of negative 2 is 2, so that'll be negative 3 times 2. Negative 3 times 2 is negative 6. Negative 6 minus 1 is negative 7. So my x-intercept will be 0, negative 7. I'm sorry, my y-intercept. My y-intercept will be 0, negative 7. Okay, so again, no x-intercepts and one y-intercept. Now, when you're doing these, remember an absolute value function. So this graph, if I'm just going to do a quick sketch, remember that this negative flips it over the x-axis, and then this is going to shift right 2 units and down 1 unit. So it'll shift right 2 units and down 1 unit, and it flips it. So it's going to look something like this. Your absolute value graph Man, I am just off today. This is 1. Okay. Your absolute value graph is a V, right? Or an upside down V. So no matter where your V is, it's going to definitely cross the y-axis at some point, right? It's going to definitely go over the y-axis. And it'll only go over it once. So you will have one y-intercept every time. Exactly one y-intercept. The x-intercepts vary though. Notice this time, since your graph is going down, it's never going to cross the x-axis, which is why you have no x-intercepts. So in this case, we have no x-intercepts. But there are other cases, and I want to just draw quick graphs. So the blue has nothing to do with this problem. This is just talking in general. I could have a graph that looks like this, where only the vertex kind of hits the x-axis. So in that case, you would have one x-intercept. And the other case is that you have, I don't know, somewhere over here or wherever, where it crosses twice. So you'll have 2 x-intercepts. But those are the only possibilities. You either have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. You always have exactly 1 y-intercept. Okay, so keep that in mind as you're working through these. All right, number 4. Find the x and y intercepts of the graph of each function. Describe in words how this function is a translation of a toolkit function, and sketch the graph. Okay, so x and y intercepts. So to find the x-intercept, I'm going to let y equal 0. So that means I have absolute value of x minus 2 plus 3 is equal to 0. So I'm going to start by getting the absolute value by itself on one side of the equal sign. So I'm going to have the absolute value of x minus 2 is equal to negative 3. Again, notice that I have the absolute value set equal to a negative. There's no solution here. That means there are going to be no x-intercepts. So if there are no x-intercepts, I'm saying that the graph will never cross the x-axis. So we'll see if that's true when we sketch the graph. Then I want to find the y-intercept. Remember, there will be exactly one y-intercept, and I'm going to find that by letting x be 0. So the absolute value of 0 minus 2 plus 3, that's going to be the absolute value of negative 2 plus 3, which is 2 plus 3, which is 5. So my y-intercept is 0, 5. Okay. So I am going to now describe in words how this function is a translation of a toolkit function. So the toolkit function is f of x equals absolute value of x. To that toolkit function, I've subtracted 2 within the function and added 3 outside of the function. So this is going to shift right 2 units, and it's going to shift up 3 units. So remember, inside the function it does the opposite of what you would think, so that's a right shift 2, and then outside of the function it does what you think it would, so it's an up shift of 3. Okay, so now I know that information. I'm going to sketch a graph. So if I sketched a graph of the parent function, I'm going to do that, or toolkit function, I'm going to do that in black. So that would be here, starts at the origin and then goes up 1 over 1 in both directions to make the V. And now I'm going to shift that appropriately. So shift right 2 units and up 3 units. So right 2, up 3, and then I'm going to go up and over 1 in both directions. So I keep the same shape. Okay, so notice that I do not cross the x-axis, so that corresponds to no x-intercepts. And I cross the y-axis at 0, 5, which corresponds to my y-intercept. So perfect. So it's just a way to check yourself. Okay, let's look at number 5. So we're going to do the same thing here. So first we want to find the x-intercepts, if we have any. We're going to let y equal 0. So we have negative absolute value of x plus 1 equals 0. So start by dividing by the negative 1. So that cancels out and gives us the absolute value of x plus 1 is equal to 0. Since we have an absolute value equal to 0, we can just solve it without the absolute value. So x plus 1 equals 0. Subtract 1 from both sides. So we get x equals negative 1. So this time we have one x-intercept. The x-intercept is negative 1, 0. Okay. Now we want to find the y-intercept. So we're going to let x be 0. So that's going to be y equals negative absolute value of 0 plus 1. It's going to be negative absolute value of 1. The absolute value of 1 is 1, and then apply the negative. So we'll have 0, negative 1 as our y-intercept. Okay, so now I want to describe in words the transformation that occurs here. So I have a negative out here that flips it over the x-axis, and this plus 1 is going to shift left 1. Okay, so this is reflects over x-axis, and this is shifts left 1 unit. Okay, so let's do the parent function. So the parent function, it starts at the origin and is a v. It goes up 1 over 1 in both directions. Okay, so now I'm going to shift left 1 unit and flip it. So here, and then flip it over like that. All right, so now, oops, I got off there. Let's see, I got off the line. Let's try one more time. So we should be going down 1 over 1. Oh, I must have done okay. All right, so there it is. So let's check our points. The x-intercept is negative 1, 0. Well, that checks out. The y-intercept is 0, negative 1. That checks out. So we probably did a pretty good job with our graph. We have it described in words. I think we did everything it asked us to do. Okay, and that's it for this section.